What if everything we believe about the universe running on perfect, predictable rules just broke down without warning, and no one noticed for hours? The cosmos has always been described as a flawless rhythm, a precise performance where planets, stars, and dust follow the strict score written by general relativity. Every movement is supposed to be calculable, dependable, and repeatable. And then, at exactly 9:15 a.m. Eastern Standard Time, that rhythm slipped. Not gradually, not subtly. It snapped. For 4 full hours, a set of high-resolution images sat quietly inside a NASA archive, ignored because there was no reason to suspect they mattered. Nothing appeared urgent. Nothing appeared wrong. Until the Goldstone Deep Space Communications Complex returned a Doppler reading that simply should not exist. Interstellar Object 3I-ATLAS was not where the equations said it would be. It hadn't drifted slightly. It hadn't curved under gravity in some unexpected but explainable way. According to verified telemetry, a mass weighing 33 billion tons had repositioned itself by roughly 300,000 miles. No debris, no heat, no visible propulsion, just relocation. As if the object had decided, deliberately, to be somewhere else. At that moment, the core question shifted. It was no longer about where 3I-ATLAS was going. It became something far more unsettling. What kind of intelligence could move a mountain across open space without leaving behind a single trace of energy loss? In classical physics, especially under Newton's law of universal gravitation, motion in space is not a mystery. Once mass, velocity, and surrounding gravitational forces are known, an object's future position can be predicted centuries ahead with astonishing accuracy. This predictability is sometimes called the music of the spheres, the idea that the universe follows a stable and beautiful mathematical harmony. But Goldstone's data revealed a rupture in that harmony. 3I-ATLAS deviated from its hyperbolic trajectory in a way that suggests controlled movement without reaction mass. That single fact forces a radical conclusion. We may be witnessing metric engineering, the manipulation of space-time itself. Theoretical models proposed by physicists like Michio Kaku suggest that an advanced civilization would not rely on chemical rockets or conventional thrust. A Type 3 civilization operating at a galactic scale would reshape space-time directly, creating localized distortions in higher dimensional space to shift position without acceleration. Before this event, 3I-ATLAS was categorized as a strange but natural interstellar visitor. Its path was charted, its closest approach calculated. Every major observatory on Earth agreed on the math. Then the math failed. To understand how extreme this failure is, consider inertial mass. Moving a 33 billion ton object 300,000 miles using known physics would require energy equivalent to thousands of nuclear weapons detonated simultaneously. Such an event would light up the solar system in infrared radiation, yet sensors recorded nothing. The object remained cold. This suggests mastery over the equivalence principle itself, the idea that gravitational mass and inertial mass are the same. If negative energy density is being used, as some models predict, then 3I-ATLAS isn't pushing through space, it's sliding through it. Simulations also show the relocation was not random. The object did not move away from Earth. It moved into a more advantageous observational position. In quantum electrodynamics, the best way to observe a planetary system is from a gravitational node. By shifting its location, 3I-ATLAS placed itself in a strategic high ground relative to Earth's orbital plane. That is not the behavior of a dead rock, it is the behavior of something watching. Images under debate suggest its surface is not ice or dust, but a highly reflective metamaterial designed to absorb radar signals. Radar-absorbent materials exist on Earth, but this level of sophistication would make modern stealth technology look primitive. Goldstone didn't just detect a new position, it detected a clean signature, no gas cloud, no fragmentation, a hard, rigid echo, one object, one structure. If 3I-ATLAS is tapping into zero-point energy at the Planck scale, it no longer needs fuel. It moves by riding the vacuum itself. As independent physicists analyze the data, a quiet consensus is forming. This was intentional. In information theory, a delimiter is a signal that marks a boundary. The relocation was a delimiter, a physical statement saying, I am here and I am not what you assumed. The way we respond may be the real test. To understand why the movement of a 33 billion-ton object by 300,000 miles has frozen the global scientific community in disbelief, we have to step deeper into the laws that supposedly govern everything. The second law of thermodynamics tells us that order decays into disorder, that systems lose usable energy over time. Conservation of momentum tells us that nothing moves without paying a price in force, heat, or reaction. These principles are not optional. They are the foundation of classical mechanics. Yet, when 3I-ATLAS moved, it didn't obey any of them. It didn't drift slowly. It didn't respond to a visible force. It violated what can only be described as the inertial blueprint of our solar system. According to verified kinematics, shifting a mass of this scale should have produced a thrust event so violent it would briefly rival the brightness of a star. The sky should have lit up. Instruments should have been overwhelmed. Instead, orbiting observatories detected something far more disturbing, a thermal profile indistinguishable from absolute zero. No heat spike, no radiation bloom, nothing. Through the Kaku framework, this forces us toward a hypothesis that sounds impossible but fits the data with uncomfortable precision. 3I-ATLAS is not pushing against space, it is pulling space toward itself. This concept, sometimes referred to as entropic displacement, suggests the object is reshaping the metric of spacetime rather than accelerating through it. On the Kaku scale, this is the signature capability of a Type 3 civilization, one that can manipulate dimensions beyond the familiar 4. Simulations show the object may have generated a localized Alcubierre bubble, a theoretical solution to Einstein's field equations where spacetime contracts in front of an object and expands behind it. In that scenario, the object itself never accelerates. Space moves instead. That single mechanism resolves the paradox. No heat is generated. No inertia is experienced. Newton's laws are not broken, they are bypassed. The forensic evidence supporting this interpretation is subtle but powerful. During the exact window of relocation, gravitational lensing data captured a phenomenon that should not exist under normal conditions. In general relativity, mass bends spacetime, causing background starlight to curve predictably. What observers saw instead was a rhythmic shimmering pattern behind 3I-ATLAS that lasted precisely 14 seconds. This was not random distortion. The geometry was ordered, repeating, and mathematically consistent. The most likely explanation is a temporary phase shift in the local gravitational constant, as if the object briefly rewrote how gravity behaved in its immediate vicinity. This alone would confirm we are not observing a natural body, but the surface imagery deepens the anomaly. High-resolution radar imaging reveals none of the chaotic erosion seen on comets or asteroids. Natural objects are scarred, fractured, and uneven after billions of years of micrometeoroid impacts. 3I-ATLAS appears smooth, symmetrical, and structured at multiple scales. Under quantum electrodynamics modeling, the surface exhibits fractal order, a hallmark of engineered materials rather than geological chance. Material scientists analyzing the data suggest the exterior may be composed of a graphene osmium lattice, a structure dense enough to withstand extreme radiation while remaining highly conductive. Such a material would function simultaneously as shielding, energy collection, and signal absorption. In other words, the object doesn't just hide from radar, it drinks it in. This would explain why the radar return is so clean and rigid. There is no scattering, no diffusion, just a precise echo from a singular monolithic structure. The relocation itself now appears less like movement and more like repositioning. In information theory, an observer seeking maximum data efficiency places itself at a gravitational equilibrium point. By shifting 300,000 miles, 3I-ATLAS effectively parked itself near a gravitational node where it can maintain a constant, stable line of sight to Earth without expending energy. Nature does not park objects in space, only intelligence does. This raises the question no one wants to ask out loud. Why reveal itself now? For months, the object behaved like an inert visitor. Then, without warning, it demonstrated a capability far beyond human reach. In game theory, this is known as a dominance signal. A move so advanced, it establishes hierarchy without aggression. It says, I can do things you cannot even model. As the object settled into its new position, Goldstone detected something new. A low-frequency hum, not in radio waves, but in the gravitational spectrum, a pulse rippling through spacetime itself. The object wasn't transmitting a message. It was altering the medium. And as the data continues to unfold, it becomes clear that this relocation was not the event. It was the preparation. Whatever comes next will force us to redefine life, technology, and our place in the universe. The deeper analysts dug into the data, the clearer it became that the relocation was not an isolated maneuver, but the opening move of a much larger sequence. At exactly 22 UTC, the Goldstone Deep Space Communications Complex confirmed something that erased any remaining doubt. 3I-ATLAS was no longer drifting at all. It had entered a precise station-keeping state. In classical orbital mechanics, this should be nearly impossible for an object of any size without continuous propulsion. For a mass measured in tens of billions of tons, it should be outright absurd. And yet, the numbers were undeniable. The object had stabilized itself within a margin of error smaller than a grain of sand on a cosmic scale. To grasp why this stunned physicists, we have to look at Lagrangian mechanics and the infamous three-body problem. In theory, there are specific locations in space where the gravitational pull of two large bodies, like the Sun and Earth, balance perfectly with orbital motion. These points are known as Lagrange points, and they are the most valuable real estate in the solar system. They allow spacecraft to remain in a fixed position relative to Earth with minimal fuel. Even then, minimal is not zero. Our most advanced observatories must constantly fire thrusters to stay locked in place. They drift. They wobble. They fight instability. 3I-ATLAS did none of that. Laser altimetry showed it holding position with a precision of 0.00001 millimeters. No exhaust, no ion trail, no chemical plume. Instead, the object exhibited something far stranger. Its entire structure was vibrating, not macroscopically, but at a subatomic frequency. The oscillation was uniform across its surface, as if the object were resonating with spacetime itself. Theoretical physicists now believe it is anchoring itself by interacting directly with quantum vacuum fluctuations, using the energy of empty space as a stabilizing force. In effect, it isn't pushing against gravity, It's stitching itself into the fabric of space-time. This realization shifted the discussion from propulsion to purpose. By occupying this position, 3I-ATLAS gained an uninterrupted view of Earth's dayside while maintaining a constant line of sight to the Sunday. From an engineering perspective, it is a flawless configuration for long-term observation and energy collection. From a strategic perspective, it looks uncomfortably like surveillance. This is not how a random interstellar rock behaves. This is how a system positions itself to watch, measure, and wait. The surface imagery added another layer of unease. High-resolution radar revealed that the object's outer lattice was not static. It was expanding and contracting in regular 14-second cycles. In solid-state physics, this behavior matches a piezoelectric response where mechanical stress generates electrical charge. But here, the scale was unprecedented. Models suggest the object is converting the kinetic energy of the solar wind directly into usable power. Protons strike the surface, the lattice flexes, and electricity is produced. No fuel tanks, no reactors. The structure itself is the power plant. This implies something even more unsettling. 3I-ATLAS is not just a machine. It behaves like a closed, self-sustaining system, capable of operating indefinitely without resupply. In biological terms, it resembles an organism. In technological terms, it represents energy logistics so advanced that scarcity no longer applies. A construct like this does not pass through a system quickly, it stays. Then came the discovery that silenced the room. When independent researchers applied a Fourier transform to what was previously dismissed as background noise in the NASA imagery, a pattern emerged. Embedded in the pixel fluctuations was a repeating geometric sequence. It was not language, it was not math in the way we write it. It was a structure built from universal constants, the speed of light, the fine structure constant, the Planck length. In quantum cryptography, this kind of encoding is known as a universal handshake, a signal designed to be recognized only by a civilization that understands the fundamental rules of reality. The implication was chilling. The relocation was not a warning, it was an invitation, a test to see if we could notice, decode, and comprehend what was being shown. As 3I-ATLAS remains perfectly still, invisible to the naked eye but loud in the gravitational spectrum, one truth is now unavoidable. Humanity is no longer unobserved. The object did not arrive when it moved. It arrived when it stopped, and whatever happens next will depend not on its technology, but on how we respond to the first undeniable proof that we are not alone, and never have been. By the time the scientific community absorbed what the station-keeping data implied, the conversation had already shifted from how 3I-ATLAS was doing this to why it chose this exact moment to reveal itself. That question became impossible to ignore when the next layer of data arrived. Roughly 12 hours after stabilization, analysts working with NASA noticed a subtle but persistent anomaly in the object's interaction with background radiation. It wasn't emitting a signal in any conventional sense. Instead, it was modulating what was already there, shaping ambient cosmic noise into a structured pattern. This is where the investigation crossed a critical threshold from exotic physics into intentional behavior. In classical astrophysics, passive objects reflect, absorb, or scatter radiation. They do not organize it. Yet the radiation field around 3I-ATLAS showed periodic coherence, as if the object were gently imprinting order onto randomness. In information theory, this matters more than raw power. Intelligence reveals itself not through energy output, but through entropy reduction, and entropy was dropping. Not dramatically, not explosively, but unmistakably. The space around the object was becoming more ordered over time. To understand why this matters, consider how we ourselves search for life. SETI does not look for loud signals first. It looks for patterns that cannot be produced by blind natural processes. Prime numbers, repeating sequences, narrow-band coherence. What 3I-ATLAS was doing fit that same logic, except on a scale that made our own efforts seem primitive. It was not shouting into the void, it was whispering into the structure of space-time itself. Gravitational data soon reinforced this conclusion. Instruments designed to monitor minute distortions in space-time detected a repeating low-amplitude wave originating from the object. This was not a catastrophic gravitational wave, like those produced by black hole mergers. It was controlled, rhythmic, and sustained. The frequency matched the oscillation of the object's surface lattice almost perfectly. In effect, 3I-ATLAS was coupling mechanical vibration, electromagnetic structure, and gravitational influence into a single synchronized system. That kind of cross-domain coherence does not happen by accident. The implications for propulsion theory were staggering. If an object can deliberately shape gravitational microfields, then movement becomes secondary. Navigation is no longer about force, but about geometry. You don't push yourself through space, you redefine where space allows you to exist. That reframes the earlier relocation event entirely. It wasn't a burst of speed, it was a rewrite of position, executed with surgical precision. At this stage, comparisons to probes or machines began to feel insufficient. The behavior matched neither a tool nor a vehicle in the human sense. It matched something closer to infrastructure. A node, a fixed intelligence platform designed to sit at key locations and observe emerging systems over long timescales. This aligns uncomfortably well with long-standing theoretical discussions of Bracewell probes, autonomous constructs sent not to communicate immediately, but to wait until a civilization becomes capable of noticing them. That waiting appears to be over. The object's current configuration allows continuous monitoring of Earth's electromagnetic emissions, from radio chatter to radar sweeps to satellite telemetry. Nothing we broadcast into space is subtle at this distance. From where 3I-ATLAS sits, our planet is loud, not just technologically, but biologically. Our atmosphere, our magnetic field, even our power grids, produce signatures that can be analyzed, cataloged, and compared against models of intelligent behavior. And then there is the timing. The object remained inert while humanity developed radio, nuclear power, digital computation, and spaceflight. It revealed its first anomaly only after we reached the ability to track interstellar objects with precision. It revealed its second only after we could measure gravitational subtleties. This sequence looks less like coincidence and more like a graduated disclosure, scaled to our capacity to observe without self-destruction through panic. The most unsettling conclusion emerging from internal discussions is also the simplest. 3I-ATLAS is not here to announce itself, it is here to evaluate. To determine whether this planetary system hosts a civilization capable of understanding higher-order physics without destabilizing itself. The object has not transmitted a message because, from its perspective, our entire planet is the message. Our reactions, our theories, our restraint, or lack of it, are the data being collected. As we move forward, the question is no longer whether something extraordinary has entered our solar system. That question is settled. The real question is whether humanity recognizes that observation cuts both ways, and whether we can respond not with fear or arrogance, but with the quiet maturity of a species realizing it has just been noticed. As the evaluation hypothesis gained traction, researchers began asking a harder question: what criteria would an intelligence like this actually be measuring? The answer did not come from astronomy first, but from systems science. Analysts working with NASA and several independent institutes noticed that the object's activity correlated less with celestial mechanics and more with human behavior. Peaks in modulation intensity appeared during periods of heavy global communication traffic. The fluctuations weren't random. They tracked moments when our planet was loudest, busiest, and most technologically expressive. From a purely physical standpoint, this made no sense. If 3I-ATLAS were studying the sun or the structure of spacetime alone, human activity would be irrelevant noise. But the data showed sensitivity to that noise, as if it were the signal. In complexity theory, this distinction is critical. Advanced observers don't look for raw strength. They look for emergent order. They look for systems capable of self-organization, feedback, and long-term stability. In other words, they look for civilizations that might survive contact with deeper layers of reality. The next discovery pushed the investigation into even more uncomfortable territory. Spectral analysis revealed that the object's surface lattice was subtly reconfiguring itself over time. Not melting, not degrading, but adjusting. The changes followed mathematical ratios associated with optimization problems, the same kinds used in artificial intelligence to refine decision-making processes. The structure wasn't static hardware. It behaved like adaptive architecture, learning from its environment and refining its interaction with it. This reframed the idea of observation entirely. 3I-ATLAS was not simply watching us. It was testing models against reality. Each adjustment suggested hypothesis refinement. Each stabilization maneuver suggested error correction. In cybernetics, this is the definition of intelligence, the ability to minimize surprise by updating internal representations of the external world. By that definition, the object was not just intelligent, it was methodical. The silence surrounding all of this has been just as revealing as the data itself. There has been no announcement, no dramatic press conference, no declaration of discovery. Instead, information has moved quietly through internal channels, academic preprints, and carefully worded technical briefings. This restraint is not accidental. It reflects an unspoken consensus that whatever 3I-ATLAS represents, it operates on timescales and power levels far beyond immediate human control. Panic would achieve nothing. Speculation without discipline would achieve less. Meanwhile, the object has remained perfectly still. No new relocations, no escalation. That, too, appears intentional. In behavioral analysis, sudden displays of power are followed by periods of inactivity to observe response. Does the subject adapt? Does it overreact? Does it attempt communication, concealment, or aggression? So far, humanity's response has been fragmented but largely cautious. Telescopes have watched. Papers have been written. Weapons have remained unfired. That restraint may matter more than any equation we solve. If 3I-ATLAS is a sentinel, its primary function may not be exploration but classification. Civilizations that react with violence to the unknown may be flagged as unstable. Those that react with curiosity tempered by caution may be marked differently. This is not speculation born of fear, but of pattern recognition. Any intelligence capable of metric engineering would understand that first contact disasters usually begin with misunderstanding, not malice. One detail has kept theorists awake at night. The object's energy intake far exceeds what is required for passive observation, yet far less than what would be needed for large-scale construction or departure. It is operating in a narrow, deliberate band. Enough power to monitor, adapt, and persist indefinitely, not enough to suggest imminent intervention. That balance feels intentional, like a system designed to remain just below the threshold of provocation. As days pass with no dramatic change, the realization becomes harder to avoid. This may be what contact actually looks like, not a landing, not a message carved in light, but a presence that forces us to confront our own level of understanding. A mirror held up by physics itself, the universe hasn't spoken in words, it has responded with behavior. And that brings us to the final and most sobering thought. If 3I-ATLAS is evaluating us, then our greatest challenge is not technological, it is philosophical. Are we capable of recognizing that intelligence does not always announce itself, and that being observed is not the same as being threatened? The answer to that question may determine not only how this chapter ends, but whether there will be another one at all. The final implication of everything we've observed is also the simplest, and that is what makes it so difficult to accept. 3I-ATLAS has done nothing overtly hostile, nothing openly benevolent, and nothing that could be interpreted as an attempt at domination. Instead, it has behaved like a system executing a long-planned protocol. Every relocation, every stabilization maneuver, every precise energy adjustment points to patience rather than urgency. In astrophysical terms, this is not a visitor passing through. It is a fixture that has integrated itself into the architecture of our solar system.